I discuss MBSE with chatGPT. Yongyo Ryu, March.24, 2023, plmiz.tstory.com. I created various questions about MBSE and asked chatGPT. This content contains the contents of the conversation with chatGPT as it is. Here is a list of 22 questions I asked chatGPT in order. Q1. I want to talk about MBSE. Q2. What is the definition of MBSE? Q3. What problems can be solved by using MBSE? Q4. MBSE lists the problems that have arisen in the past and the improvement plans for each problem. Q5. What will be the difference compared to the existing method by applying MBSE? Q6. What skills will you need? Q7. Why should companies do MBSE? Q8. What's the problem if companies don't do MBSE? Q9. What is the MBSE effect? Q10. What problems does MBSE solve in the past? Please list each one as an example. Q11. If MBSE is a national project, what role should the state play? Q12. We are trying to build a reference for each industry with MBSE as a project with government budget. Please describe what the government should do and what businesses should do. Q13. If you are going to take the MBSE as a 4-step task, please make a plan for each step. Q14. How to implement MBSE in cloud. Q15. What do you like about MBSE? Q16. Separately describe the quantitative and qualitative effects of MBSE. Q17. What is the MBSE performance indicator? Q18. Which country is the most advanced in MBSE? Q19. Please tell me which companies use MBSE well. Q20. List examples of MBSE by industry. In order of automobile, aviation, shipbuilding, and electronics industries. Q21. I want to know MBSE development indicators. In particular, I am curious about the performance goals for each indicator. Q22. Still, MBSE is not easily explained. Can you easily explain what the difference is and how it works? It's so that people who don't know much about IT can easily understand it when they see it. Right from this point of view, when you read the technical content, please write clearly what you want to do. Q1. I want to talk about MBSE. MBSE stands for Model-Based Systems Engineering, which is a model-based system engineering concept. We describe the system using a model to eliminate the ambiguity of commercial language. Q2. What is the definition of MBSE? MBSE stands for Model-Based Systems Engineering, which is a methodology that uses system models as a central reference point throughout the entire engineering process, from design to verification and validation. It aims to improve the efficiency and effectiveness of systems engineering by providing a common language and framework for all stakeholders to communicate, collaborate, and make decisions. The models can capture various aspects of the system, such as requirements, design, behavior, and performance, and can be used to simulate and analyze system behavior, validate requirements, and identify design flaws early in the development process. Q3. What problems can be solved by using MBSE? MBSE helps you solve problems in the systems engineering process 1. For example, MBSE can be used to increase requirements traceability, reduce system complexity, and improve understanding of system structure and behavior. Why use MBSE? The reason why MBSE is used is that the system is described using a model to avoid the ambiguity of commercial language 12. MBSE helps you solve problems in the systems engineering process 3. For example, MBSE can be used to increase requirements traceability, reduce system complexity, and improve understanding of system structure and behavior. Sure, I'd be happy to discuss MBSE. MBSE stands for Model-Based Systems Engineering, which is an approach to systems engineering that emphasizes the use of models to support the development, analysis, and verification of complex systems. In MBSE, models are used to capture the requirements, design, behavior, and other aspects of the system under development. These models can be created and manipulated using various modeling languages and tools, such as SYSML, UML, or Modelica. The benefits of using MBSE include improved communication and collaboration among stakeholders, increased clarity and consistency of system requirements and design, and better ability to analyze and validate system behavior before implementation. Do you have any specific questions or topics you'd like to discuss related to MBSE? Q4. MBSE lists the problems that have arisen in the past and the improvement plans for each problem. MBSE emerged as a response to several challenges in traditional systems engineering approaches, including 1. Increasing complexity of systems. As systems become more complex, traditional documentation-based approaches to systems engineering become more difficult to manage and maintain. 2. Limited tool support. Traditional systems engineering approaches often rely on paper-based documentation and manual processes, which can be time-consuming and error-prone. 3. Poor communication and collaboration. Traditional systems engineering approaches often result in siloed teams and poor communication and collaboration between stakeholders. 4. To address these challenges, MBSE introduces a model-based approach to systems engineering that offers several potential improvements, such as 5. Improved visualization and analysis. By representing system requirements, design, and behavior in models, MBSE offers improved visualization and analysis capabilities compared to traditional documentation-based approaches. 6. Increased automation. MBSE offers increased automation through the use of modeling tools, which can automatically generate documentation and support analysis and verification activities. 7. Enhanced communication and collaboration. MBSE offers enhanced communication and collaboration between stakeholders by providing a common language and set of models that can be shared and understood by all members of a project team. Overall, MBSE offers a promising approach to address the challenges of traditional systems engineering and can lead to improved system design and development processes. However, adoption of MBSE requires significant changes to organizational processes, tools, and culture, which can be challenging to implement.
Q5. What will be the difference compared to the existing method by applying MBSE? Applying MBSE can result in several benefits compared to traditional systems engineering approaches. Some of the key differences include 1. Increased clarity and consistency. MBSE provides a structured, model-based approach that can lead to increased clarity and consistency in system requirements, design, and behavior. This can help reduce misunderstandings and errors, and improve the overall quality of the system. 2. Improved communication and collaboration. MBSE offers a common language and set of models that can be shared and understood by all members of a project team, improving communication and collaboration between stakeholders. 3. Better analysis and validation. MBSE allows for the use of automated tools and simulations to analyze and validate system behavior before implementation, reducing the risk of errors and ensuring that the system meets requirements. 4. Greater efficiency. MBSE can help streamline the system development process by reducing the need for manual documentation and enabling more efficient collaboration between team members. Overall, applying MBSE can lead to improved system design and development processes, resulting in better quality, more efficient, and more effective systems. However, it also requires significant changes to organizational processes, tools, and culture, which can be challenging to implement. Q6. What skills will you need? Implementing MBSE requires the use of various tools and technologies to support modeling, analysis, and collaboration activities. Some of the key technologies that are commonly used in MBSE include 1. Modeling languages. MBSE relies on the use of modeling languages, such as SYSML, UML, or Modelica, to create and manipulate system models. 2. Modeling tools. Modeling tools, such as IBM Rhapsody, MagicDraw, or Cameo Systems Modeler, are used to create, visualize, and manipulate system models. These tools often include automated analysis and simulation capabilities. 3. Requirements management tools. Requirements management tools, such as DOORS, JAMA, or PTC Integrity, are used to manage system requirements, traceability, and verification activities. 4. Configuration management tools. Configuration management tools, such as Git or SVN, are used to manage changes to system models and other project artifacts. 5. Collaboration tools. Collaboration tools, such as Confluence, Jira, or Microsoft Teams, are used to support communication and collaboration among project stakeholders. 6. Simulation and analysis tools. Simulation and analysis tools, such as MATLAB, Simulink, or ANSYS, are used to simulate system behavior and verify system requirements. Overall, implementing MBSE requires the use of a range of tools and technologies that support modeling, analysis, and collaboration activities. Successful implementation also requires a strong understanding of systems engineering principles and practices, as well as organizational buy-in and support for the MBSE approach. Q7. Why should companies do MBSE? There are several reasons why a company may want to adopt MBSE as part of their systems engineering approach, including 1. Improved quality and reliability. MBSE can lead to improved system quality and reliability by providing a structured approach to system design and development that ensures requirements are clearly defined and met. 2. Reduced risk and cost. By enabling earlier detection and resolution of design issues, MBSE can help reduce the risk of costly rework and delays. 3. Enhanced collaboration. MBSE provides a common language and set of models that can be shared and understood by all members of a project team, improving communication and collaboration between stakeholders. 4. Increased efficiency. MBSE can help streamline the system development process by reducing the need for manual documentation and enabling more efficient collaboration between team members. 5. Better support for system maintenance and upgrades. MBSE can help ensure that system documentation is up to date and accurate, making it easier to maintain and upgrade the system over time. Overall, adopting MBSE can lead to improved system design and development processes, resulting in better quality, more efficient, and more effective systems. However, it also requires significant changes to organizational processes, tools, and culture, which can be challenging to implement. Companies must carefully consider the costs and benefits of adopting MBSE and develop a plan for successful implementation. Q8. What's the problem if companies don't do MBSE? There are several potential problems that a company may face if they choose not to adopt MBSE as part of their systems engineering approach, including 1. Inconsistent and unclear requirements. Without a structured approach to requirements management, there is a risk of unclear or inconsistent requirements, which can lead to misunderstandings and errors in the design and development process. 2. Inefficient development processes. Without the use of modeling and simulation tools, system development may be slower and more costly, requiring significant manual documentation and testing. 3. Poor communication and collaboration. Without a common language and set of models, communication and collaboration among project stakeholders may be more difficult, leading to misunderstandings and delays. 4. Increased risk of errors and rework. Without the use of automated analysis and simulation tools, there is a greater risk of errors in the system design and development process, which can lead to costly rework and delays. 5. Difficulty in maintaining and upgrading systems. Without accurate and up-to-date system documentation, it may be more difficult to maintain and upgrade systems over time, leading to increased costs and decreased system effectiveness. Overall, not adopting MBSE can lead to a range of problems that can negatively impact the quality, efficiency, and effectiveness of a company's system design and development processes. Q9. What is the MBSE effect? The potential benefits of implementing MBSE as part of a systems engineering approach can include 1. Improved system quality. MBSE can lead to improved system quality by ensuring that system requirements are clearly defined, validated, and met. 2. Reduced risk and cost. By enabling earlier detection and resolution of design issues, MBSE can help reduce the risk of costly rework and delays. 3. Enhanced collaboration. MBSE provides a common language and set of models that can be shared and understood by all members of a project team, improving communication and collaboration between stakeholders. 4. Increased efficiency. MBSE can help streamline the system development process by reducing the need for manual documentation and enabling more efficient collaboration between team members. 5. Better support for system maintenance and upgrades. MBSE can help ensure that system documentation is up to date and accurate, making it easier to maintain and upgrade the system over time. 6. Improved decision-making. By providing a comprehensive and accurate view of the system, MBSE can help stakeholders make more informed decisions about system design and development. Overall, implementing MBSE can lead to a range of benefits, including improved system quality, reduced risk and cost, enhanced collaboration, increased efficiency, better support for system maintenance and upgrades, and improved decision-making. However, successful implementation requires significant changes to organizational processes, tools, and culture, and may require significant upfront investment. Q10. What problems does MBSE solve in the past? Please list each one as an example. MBSE addresses several issues that can arise with traditional systems engineering approaches. Here are some examples. 1. Incomplete or inconsistent requirements. Traditional systems engineering approaches may not provide a consistent way to capture and manage system requirements. MBSE provides a structured approach to requirements management, ensuring that requirements are clearly defined and traceable throughout the system development process. 2. Lack of visibility into system behavior. Traditional systems engineering approaches may not provide a comprehensive view of system behavior, making it difficult to predict how the system will perform in different scenarios. MBSE enables modeling and simulation of system behavior, allowing stakeholders to explore system behavior and evaluate design decisions before implementation. 3. Difficulty in managing complexity. Traditional systems engineering approaches may struggle to manage the complexity of modern systems, which can include multiple subsystems and interfaces. MBSE provides a way to model and manage system complexity, ensuring that all system components are clearly defined and understood. 4. Communication and collaboration challenges. Traditional systems engineering approaches may rely on manual documentation and can make it difficult for stakeholders to collaborate effectively. MBSE provides a common language and set of models that can be shared and understood by all members of a project team, improving communication and collaboration among stakeholders. 5. Limited ability to handle change. Traditional systems engineering approaches may not be flexible enough to handle changes to system requirements or design decisions. MBSE enables rapid iteration and refinement of system models, making it easier to adapt to changing requirements and design decisions. Overall, MBSE addresses several challenges that can arise with traditional systems engineering approaches, including incomplete or inconsistent requirements, lack of visibility into system behavior, difficulty managing complexity, communication and collaboration challenges, and limited ability to handle change. By providing a structured, model-based approach to system design and development, MBSE can help organizations develop better quality, more efficient, and more effective systems. Q11. If MBSE is a national project, what role should the state play? If a country were to undertake an MBSE project, its role would depend on the specific goals and objectives of the project. Here are some possible roles that a country could play. 1. Project sponsor. The country could serve as the primary sponsor of the project, providing funding and resources to support the project team. 2. Regulatory authority. The country could establish regulations and guidelines for MBSE adoption and implementation, ensuring that projects adhere to established standards and best practices. 3. Knowledge repository. The country could serve as a central repository of MBSE knowledge and expertise, providing guidance and support to project teams as they adopt and implement MBSE. 4. Collaborator. The country could collaborate with industry, academic, and research institutions to promote the development and adoption of MBSE. 5. Facilitator. The country could facilitate communication and collaboration among project teams, stakeholders, and other participants in the MBSE ecosystem. Overall, the role of a country in an MBSE project will depend on the specific needs and objectives of the project. The country could play a variety of roles, including project sponsor, regulatory authority, knowledge repository, collaborator, or facilitator, among others. Q12. We are trying to build a reference for each industry with MBSE as a project with government budget. Please describe what the government should do and what businesses should do. If a government were to undertake an MBSE project to build an industry-specific reference model using government budget, the responsibilities of the government and industry could be divided as follows. Government responsibilities. 1. Funding. The government would provide funding for the project, including the necessary resources and personnel to support the project team. 2. Project management. The government would manage the overall project, including setting project goals, defining project scope, and managing project timelines and milestones. 3. Establishing standards and guidelines. The government would establish standards and guidelines for the reference model development, ensuring that the reference model meets industry needs and adheres to established best practices. 4. Knowledge sharing. The government would share the knowledge and expertise gained from the project with industry stakeholders and other interested parties, promoting the adoption and implementation of MBSE in the industry. Industry responsibilities. 1. Providing subject matter expertise. Industry experts would provide subject matter expertise to the project team, ensuring that the reference model is aligned with industry needs and standards. 2. Validating the reference model. Industry stakeholders would validate the reference model, ensuring that it accurately represents industry processes and practices. 3. Implementation. Industry would implement the reference model within their organizations, ensuring that the benefits of MBSE are realized in practice. 4. Continuous improvement. Industry stakeholders would work with the government and other stakeholders to continuously improve the reference model, ensuring that it remains relevant and useful over time. Overall, the government would be responsible for funding and managing the project, establishing standards and guidelines, and sharing knowledge and expertise gained from the project. The industry would be responsible for providing subject matter expertise, validating the reference model, implementing it within their organizations, and continuously improving it. By working together, the government and industry can create an effective industry-specific MBSE reference model that meets the needs of all stakeholders. Q13. If you are going to take the MBSE as a 4-step task, please make a plan for each step. If you want to perform an MBSE project in 4 stages, here is a possible plan for each stage. Stage 1. Planning. 1-1. Identify the scope of the project, including the system or systems to be modeled. 1-2. Determine the project goals and objectives, including the expected benefits of MBSE. 1-3. Establish project timelines and milestones, including key decision points and deliverables. 1-4. Assemble the project team, including subject matter experts, modelers, and other stakeholders. 1-5. Develop a communication plan, including regular project updates and stakeholder engagement. Stage 2. Requirements definition. 2-1. Collect and analyze stakeholder requirements, including user needs, technical specifications, and regulatory requirements. 2-2. Develop a requirements traceability matrix, linking system requirements to stakeholder needs and other requirements. 2-3. Use modeling tools to capture system requirements and constraints, including use cases, functional requirements, and non-functional requirements. 2-4. Validate the requirements with stakeholders and other subject matter experts. 2-5. Refine the requirements as needed to ensure they are complete, accurate, and traceable. Stage 3. Design and development. 3-1. Use modeling tools to develop a conceptual design for the system, including system architecture and interfaces. 3-2. Develop detailed design models for each component of the system, including physical and logical views. 3-3. Use simulation and other analysis tools to validate the design, including performance, safety, and reliability analyses. 3 to 4. Develop the software and hardware components of the system, using agile development methodologies as appropriate. 3 to 5. Integrate the components into a working prototype or system. Stage 4. Validation and verification. 3 to 6. Conduct system testing, including functional and non-functional testing, to verify that the system meets stakeholder requirements and other specifications. 3 to 7. Conduct formal verification and validation of the system, including peer reviews, testing, and analysis. 3 to 8. Use modeling tools to trace requirements to system components and test cases, ensuring that all requirements have been satisfied. 3 to 9. Perform a final system validation, including acceptance testing with stakeholders and other subject matter experts. 3 to 10. Document and communicate the results of the validation and verification process, including any issues or changes that were identified during testing. Overall, this 4-stage MBSE project plan includes planning, requirements definition, design and development, and validation and verification. Within each stage, there are specific activities and deliverables that must be completed to ensure the success of the project. Q14. How to implement MBSE in cloud. To implement MBSE in the cloud, you could follow these general steps. 1. Select a cloud service provider that offers the required compute and storage resources, as well as tools for developing, managing, and deploying MBSE models. 2. Decide which MBSE tools and applications to use, and ensure that they are compatible with the cloud environment. Consider factors such as scalability, performance, security, and cost. 3. Develop a cloud architecture that supports MBSE, including network connectivity, storage, security, and access controls. 4. Migrate existing MBSE models and data to the cloud, ensuring that they are properly secured and backed up. 5. Configure the MBSE tools and applications in the cloud, including customizing settings and integrating with other cloud-based services as needed. 6. Train users on how to access and use the MBSE tools and applications in the cloud, and provide ongoing support and maintenance. 7. Monitor and optimize the cloud-based MBSE environment, including monitoring performance, managing costs, and responding to any issues or changes. By following these steps, you can leverage the benefits of cloud computing for MBSE, such as improved scalability, agility, and cost efficiency. However, it is important to carefully plan and execute the migration to ensure that the MBSE environment in the cloud is secure, reliable, and optimized for your specific needs. Q15. What do you like about MBSE? There are several benefits to using MBSE. 1. Improved collaboration. MBSE enables multiple teams and stakeholders to work on the same model simultaneously, promoting collaboration and communication. 2. Increased efficiency. MBSE automates many manual processes and allows for faster and more accurate design, analysis, and verification, reducing the time and cost of development. 3. Enhanced quality. MBSE provides a systematic and rigorous approach to engineering, helping to ensure that requirements are met, designs are correct, and risks are identified and mitigated. 4. Better decision-making. MBSE provides a holistic view of the system and its components, enabling stakeholders to make informed decisions based on accurate and up-to-date information. 5. Greater flexibility. MBSE allows for easy iteration and modification of designs, making it easier to adapt to changing requirements or customer needs. Overall, MBSE can help organizations to streamline their engineering processes, reduce costs, improve quality, and accelerate time to market, making it a valuable tool for many industries. Q16. Separately describe the quantitative and qualitative effects of MBSE. Quantitative benefits of MBSE include: 1. Reduced development time and cost. MBSE enables faster and more efficient design, analysis, and verification, leading to shorter development cycles and lower costs. 2. Improved product quality. MBSE ensures that requirements are properly defined and met, designs are accurate and complete, and risks are identified and mitigated, leading to higher product quality. 3. Increased productivity. MBSE automates many manual processes, enabling engineers to focus on higher-level tasks and improving overall productivity.
Qualitative benefits of MBSE include 1. Improved collaboration and communication. MBSE promotes better communication and collaboration among stakeholders, leading to better alignment and understanding of project goals and requirements. 2. Better decision-making. MBSE provides a holistic view of the system, enabling stakeholders to make informed decisions based on accurate and up-to-date information. 3. Greater flexibility and adaptability. MBSE allows for easy iteration and modification of designs, making it easier to adapt to changing requirements or customer needs. 4. Enhanced risk management. MBSE helps identify and mitigate risks early in the development process, reducing the likelihood of costly delays or failures. Overall, MBSE provides both quantitative and qualitative benefits to organizations, helping them to improve their engineering processes, reduce costs, improve quality, and accelerate time to market. Q17. What is the MBSE performance indicator? MBSE performance metrics can vary depending on the specific goals and objectives of the organization. Some common performance metrics for MBSE include 1. Development time. This metric measures the time it takes to complete the development process, from requirements definition to delivery. 2. Cost reduction. This metric measures the reduction in costs achieved through the use of MBSE, including reduced development time, lower rework costs, and improved productivity. 3. Product quality. This metric measures the quality of the final product, including the accuracy of design, adherence to requirements, and overall customer satisfaction. 4. Risk management. This metric measures the effectiveness of MBSE in identifying and mitigating risks early in the development process, reducing the likelihood of costly delays or failures. 5. Collaboration and communication. This metric measures the effectiveness of MBSE in promoting collaboration and communication among stakeholders, leading to better alignment and understanding of project goals and requirements. 6. Innovation. This metric measures the ability of MBSE to promote innovation and creativity in the development process, leading to new and improved products. By tracking these performance metrics, organizations can assess the effectiveness of their MBSE implementation and identify areas for improvement. Q18. Which country is the most advanced in MBSE? It is difficult to say which country is the most advanced in MBSE, as many countries have active research and development efforts in this field. However, some countries with significant MBSE initiatives and investments include the United States, Germany, France, the United Kingdom, Japan, and South Korea. These countries have established research centers, academic programs, and industry partnerships focused on advancing MBSE technology and applications. Ultimately, the success of MBSE will depend on the widespread adoption and integration of these practices across various industries and organizations, rather than just in one particular country. Q19. Please tell me which companies use MBSE well. There are many companies that have successfully implemented MBSE practices to improve their product development processes. Some examples include 1. Airbus. Airbus uses MBSE to model and simulate the design of their aircraft systems, leading to increased efficiency and reduced development costs. 2. Ford. Ford Motor Company uses MBSE to model and analyze their complex automotive systems, allowing them to identify and resolve design issues early in the development process. 3. Raytheon. Raytheon uses MBSE to design and develop complex defense systems, leading to improved collaboration, reduced development time, and higher quality products. 4. NASA. NASA uses MBSE to design and develop space exploration systems, enabling them to model and simulate complex systems and test designs in a virtual environment. 5. Siemens. Siemens uses MBSE to design and develop complex industrial systems, leading to improved efficiency, reduced development time, and higher quality products. These companies demonstrate the potential benefits of MBSE when applied effectively to product development processes. However, it is important to note that the success of MBSE implementation depends on the specific needs and goals of each organization, and may require customized approaches and solutions. Q20. List examples of MBSE by industry. In order of automobile, aviation, shipbuilding, and electronics industries. Here are some examples of MBSE applications in various industries, in order of automotive, aerospace, shipbuilding, and electronics. 1. Automotive. MBSE is used in the automotive industry to model and simulate vehicle systems, such as engines, transmissions, and electrical systems. For example, Ford uses MBSE to model and analyze their vehicle systems to identify and resolve design issues early in the development process. 2. Aerospace. MBSE is widely used in the aerospace industry to design and develop complex systems, such as aircraft and spacecraft. For instance, Airbus uses MBSE to model and simulate the design of their aircraft systems, leading to increased efficiency and reduced development costs. 3. Shipbuilding. MBSE is also used in the shipbuilding industry to design and develop complex marine systems. For example, the Royal Navy of the United Kingdom has adopted MBSE practices to model and simulate their naval systems, leading to improved collaboration and reduced development time. 4. Electronics. In the electronics industry, MBSE is used to design and develop complex electronic systems, such as consumer electronics and telecommunication systems. For instance, Siemens uses MBSE to design and develop complex industrial systems, leading to improved efficiency, reduced development time, and higher quality products. Overall, MBSE has applications across various industries and can provide benefits such as improved collaboration, reduced development time, and higher quality products. Q21. I want to know MBSE development indicators. In particular, I am curious about the performance goals for each indicator. There are several key performance indicators, KPIs, that can be used to measure the success of an MBSE project. Some common KPIs include 1. Requirements traceability. This measures the extent to which requirements are traced to their implementation in the system. The goal is to achieve 100% traceability, ensuring that all requirements are met by the system design. 2. System quality. This measures the overall quality of the system design. This can be evaluated using metrics such as reliability, maintainability, and performance. 3. Development time. This measures the time it takes to develop the system design. The goal is to reduce development time, which can lead to cost savings and faster time to market. 4. Cost savings. This measures the cost savings achieved by using MBSE. This can include savings from reduced rework, reduced development time, and improved collaboration. 5. Team collaboration. This measures the extent to which the project team is able to collaborate effectively using MBSE. The goal is to improve team collaboration, which can lead to improved system design and faster development time. Each of these KPIs has its own specific goals and targets, which will depend on the specific MBSE project and its objectives. For example, the goal for requirements traceability might be to achieve 100% traceability, while the goal for development time might be to reduce it by 20%. By monitoring these KPIs, project managers can track the progress of their MBSE project and make adjustments as needed to achieve their goals. Q22. Still, MBSE is not easily explained. Can you easily explain what the difference is and how it works? It's so that people who don't know much about IT can easily understand it when they see it. Right from this point of view, when you read the technical content, please write clearly what you want to do. Sure, I'll try my best to explain MBSE in simpler terms. MBSE stands for Model-Based Systems Engineering. It's a method of designing and developing complex systems, such as cars, airplanes, and electronic devices, using models instead of traditional documents. So what does that mean? In the past, engineers would create large volumes of documents, such as requirements, specifications, and design documents, to describe how a system should work. This approach could lead to errors, inconsistencies, and miscommunications among the team members. With MBSE, instead of relying on documents, engineers create models using specialized software tools. These models are like digital blueprints that describe how the system should function, from its components to its behavior. By using models, engineers can ensure that all team members have a consistent understanding of the system and can work together more effectively. MBSE has several benefits over traditional methods, such as 1. Improved collaboration. MBSE promotes collaboration among team members by creating a common language and understanding of the system. 2. Early error detection. Since MBSE allows engineers to simulate and test the system before building it, errors can be detected and fixed early in the development process. 3. Faster time to market. By using models, MBSE reduces the time required to create, review, and update documents, leading to faster development cycles and time to market. 4. Better quality. MBSE helps ensure that all requirements are met and that the system is built to specification, leading to higher quality products. I hope this explanation helps clarify what MBSE is and how it can benefit the engineering process. Yongyo Ryu. I am working as a managing director at D1 Company, Limited. Starting with automotive seat design work such as EF Sonata and XG Grandeur, he has conducted global business through global IT companies such as SGI, Siemens, Oracle, and PTC for 16 years, and is again performing field-oriented platform-based engineering services. #YouTube PLM Cafe, #PLM Listener, #Value Designer. Email yongyo.ryu@gmail.com. Blog plmis.tstory.com.